Okay, question number two. An ordinary fair die is thrown until a 6 is obtained. Find the probability that obtaining a 6 takes more than 8 throws. Number of trials? Missing. There's no number of trials given. It just says an ordinary fair die is thrown until a 6 is obtained. Okay. Find the probability that obtaining a 6 takes more than 8 throws. More than 8 throws out of how many throws? Out of 50, 10, 20. So n is missing. So whenever n is missing, there is no n given. So that means this is a geometric distribution. So we know that this is a geometric distribution, which is expressed like this. We're getting a 6. The probability of getting a 6 is 1 over 6. Not getting a 6, that's q, 1 minus p, that's 5 over 6. It says takes more than 8 throws. For more than 8 throws, we know that the formula for x is greater than r, whatever the required is. So it's greater than 8 throws. That's equals to qr. This is the formula that we have for geometric distribution for more than throws, for anything that's more than the given requirement. So we need to find x is greater than 8, more than 8 throws. So we have this as q, which is 5 over 6 to the power of 8. And we get this as 0.233 as our answer to the first A part. Now part B, it says two ordinary fair dice are thrown together until a pair of sixes is obtained. The number of throws taken is denoted by the random variable x. Find the expected value of x. So what's the probability of getting a 6? The probability of getting a 6 is for two sixes, two consecutive 6, that's going to be 1 over 6 times 1 over 6, which is going to be 1 over 36. So you get a 6 and you get a 6. So the probability of getting one 6 is 1 over 6 and another 6 is 1 over 6. So probability of getting two 6s, 6 and a 6, 6 and a 6. So whenever you have and, you multiply. So that's 1 over 36. So that's the probability of getting two 6s. Two 6s, that is. So that's 1 over 36. We have to find the expected value. Now, we know that in geometric distribution, we have the expected value formula as Ex is equal to 1, which is mu, basically. So Ex is equal to the mean, which is mu, and which is equal to 1 over P. So Ex over here in this case is 1 over P and 1 over P, and the probability of getting two sixes is 1 over 36. So 1 divided by 1 over 36 is just going to give you 36. So that is the answer to part B. Part C, find the probability that obtaining a pair of sixes takes either 10 or 11 throws. So it can take 10 throws, or if we have or, then we use plus, or 11 throws. So this is equal to 10 and this is equal to 11, since it tells you it's going to take 10 or 11 throws. So whenever we have Px is equal to R, we have the formula for geometric distribution as P times Q to the power of R minus 1. So this is what we're going to use for 10 and 11 both. So if we use this for 10, we have probability of x is equal to 10, which is 1 over 36, the probability of getting two sixes, multiplied by q, not getting two sixes, that's 35 over 36, to the power of, this is 10, which is 10 minus 1, so that's going to be 9. Now we do the same for, it's in 11 throws, exactly 11 throws, so that's going to be 1 over 36, that's p times q, 35 over 36, to the power of n minus r minus 1, so that's 11 minus 1, so that's to the power of 10 in this case. So now we just add the two up, like over here, 10 plus 11. So we add these two up, 10 and 11, whatever we get for these two, and we will be getting 0.0425 square to 3SF as our answer. And that's the complete question.